Understanding algorithm efficiency.
The algorithm efficiency measures how well a computer program solves a problem using time and resources. Not all solutions are created equal. Some are faster or use less memory. That's why, in computer science, we use special methods to compare approaches. One of the most important and widely used methods for this is called Big O notation.
What is Big O notation?
Big O notation is a system for describing how the time or space an algorithm needs grows as the size of its input increases. Instead of focusing on exact numbers, Big O summarizes the general trends and shows how fast things get slower or take up more memory as tasks get larger.
Common examples of Big O.
Some common Big O notations include O of 1 for constant time, O of n for linear time, and O of n squared for quadratic time. For example, looking up a single number in a list might be O of 1, while checking every number one by one could be O of n. Sorting algorithms can be O of n log n, or even slower.
Why does Big O matter?
Choosing an algorithm with a better Big O can make a big difference, especially with large amounts of data. An inefficient algorithm might work fine with a small list, but can become extremely slow or use too much memory as the data grows. Understanding Big O helps developers build more efficient software.
Key takeaways about Big O.
Big O notation gives us a standard way to discuss and compare the efficiency of algorithms. It doesn't cover every detail, but it's essential for planning, writing, and improving code. By paying attention to Big O, even beginners can make smarter choices and write faster programs.